Hi, so this is a short video showing the simulation of the servo tester circuit using the 555 IC. So I'll dive straight in. So we've got power and ground to the 555, and that is supplied through this LM7805 voltage regulator to give us a fixed 5 volts. So pin 8 is power, pin 1 is ground. We also tie the reset to power, which is 5 volts obviously, and we tie the control voltage through this 0.1 microfarad capacitor to ground. Now at the initial stages, when everything's first started and is powered on, you've got 0 volts at the trigger and at the threshold. So that makes the 555 go into the on state, and it will remain in the on state while this capacitor is being charged. And this capacitor is charged through this network of resistors. So we've got this one and this one, which could be a single resistor. So we've got a 1k and a 4k resistor, then a 10k pot, which we can then adjust through this diode, and that then charges this capacitor. That charges up and it will reach 2/3 of VCC, and then it will activate the threshold pin, which will turn the output off. That then causes the capacitor to discharge through the discharge pin. So the capacitor then discharges through this resistor along this leg to here to discharge. So this diode means that the capacitor just charges through this network and then discharges through this network. So I'm going to run the simulation. So if I do start simulation, you'll see that as I turn this potentiometer clockwise, it's actually reducing the resistance through this leg. So I've set a potentiometer up here with a multimeter. So if you look, it's 100k with it fully anti-clockwise, and then when I go fully clockwise, it's 0 ohms. So as you can see, I'm reducing the resistance as I turn it clockwise, and that in turn reduces the time it takes to charge up this capacitor, and then reduces the on period for the output. So the length of this on period determines the position of the servo, and I'll go more detail into that when I do my write-up. So if you look, we've got an on period, and that actually varies between about 0.8 and 2.2 milliseconds to give our full range of motion on the servo. So I'm just going to stop the simulation and restart it. So if you look, that gives us our range of motion. So normally these hobby servos work at 50 Hertz. Ours isn't quite that, because we've got a fixed output, fixed discharge time. So the discharge time is through this 100k ohm resistor, and that gives us an approximately 15 millisecond off period, which we fix, and then we vary our on period. So I hope that gives you some insight in how the circuit works. I'm going to do some more detail in the write-up showing the calculations and things like that, and there's also another video and write-up on how I designed the circuit and the PCB to go with this. But I thought Tinkercad is a good way to actually demonstrate how the circuit works. Thanks for watching.